Welcome back, stargazers. In our last journey through the solar system, we delved into some extraordinary anomalies that make our solar system special. We explored the slow retrograde rotation of Venus, the mysterious bright spots of Ceres, the enigmatic dark side of Iapetus, and the planet-sized dust storms of Mars. If you missed that episode, be sure to check it out to catch up on our journey. There's a link in the description. Today, we will uncover more anomalies of our cosmic neighborhood that make it unique. Get ready to explore some of the most intriguing phenomena of our solar system. But before we begin, don't forget to show your support by hitting the like button and subscribing to the channel. Have you ever wondered why some dwarf planets have multiple moons, while the larger Mercury and Venus have none? Well, it has to do with their location in the solar system. Mercury and Venus are located much closer to the Sun, where its tidal forces and solar winds disrupt the formation of moons around them. Meanwhile, dwarf planets like Pluto are located in the distant Kuiper belt, where they can more easily capture moons. But did you know that even asteroids can have moons? These moons can be captured by their parent asteroid or form from collisions between asteroids. Notable examples include the asteroid 243 Ida, which has a small moon called Dactyl, discovered in 1993 by the Galileo spacecraft, and 87 Sylvia, a main belt asteroid that has two moons, Romulus and Remus, discovered in 2001 and 2005 respectively using ground-based telescopes. You might think that every single object in the solar system orbits the Sun in the same direction. But there are actually some exceptions, objects that have retrograde orbits, meaning they orbit the Sun in the opposite direction. Common causes include gravitational interactions, like close encounters with large planets such as Jupiter, that can alter an object's orbit. Significant collisions with other objects that can reverse the direction of its orbit and produce fragments that end up in retrograde orbits. And capture by the Sun for objects from the Kuiper belt and Oort cloud, whose orbits originate outside the solar system and later get captured by the Sun's gravity. Examples of objects with retrograde orbits include Halley's Comet. Known since ancient times, it has a highly elliptical and retrograde orbit, completing one orbit every 76 years. 2008 KV-42, also known as Drac, a notable trans-Neptunian object with an orbital period of around 273 years, discovered in May 2008 by the Canada-France-Hawaii telescope. And asteroid 2015 BZ509, discovered in 2015. It is the first known asteroid to share Jupiter's orbit in a retrograde direction, suggesting it may have originated outside the solar system. Besides its stunning rings, Saturn has a feature that puzzled astronomers: its hexagon, observed in its atmosphere near its north pole. It is a persistent atmospheric cloud pattern characterized by a six-sided shape, with each side approximately 14,500 kilometers long, larger than Earth's diameter. This hexagonal shape was first discovered in images taken by the Voyager spacecraft during their flybys of Saturn in 1980 and 1981. Later, observations by the Cassini spacecraft, which orbited Saturn from 2004 to 2017, provided more detailed images of this structure. The hexagon is believed to result from complex interactions between Saturn's atmosphere and its rotation. The exact mechanism causing the hexagonal shape is not fully understood, but it is likely related to the planet's powerful jet streams and the stability provided by Saturn's rotation. This anomaly is not related to objects that orbit the Sun, but to the Sun itself, specifically its corona, the outermost layer of its atmosphere, which extends millions of kilometers into space. Surprisingly, the corona is much hotter than the Sun's surface, reaching temperatures of millions of degrees Celsius compared to about 5,500 degrees Celsius for its surface. This is known as the coronal heating problem. Typically, one would expect temperatures to decrease with distance from a heat source like the Sun, but that is not what occurs in the corona. Several theories explain this phenomenon. One suggests that the Sun's strong magnetic fields, twisted by its rotation and convection processes, store immense energy. Another involves waves traveling through the Sun's atmosphere, transferring heat like waves in water. Additionally, small explosive events called nanoflares and accelerated particles may also heat the corona. In our exploration of the solar system's anomalies, we've uncovered mysteries from asteroids with moons to objects orbiting the Sun in reverse. Saturn's enigmatic hexagon and the Sun's blazing corona defy convention, challenging our understanding of these celestial marvels. Join us as we delve deeper into these cosmic puzzles, revealing the extraordinary diversity and complexity of our celestial neighborhood. Thanks for watching. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more fascinating content. Until next time, keep looking up at the wonders above, stargazers.